Hi guys, today we're going to talk about mechanisms. I know we've been discussing mechanisms, so what is a mechanism? A mechanism is a part of a machine which contains two or more pieces arranged so that the motion of one compels the motion of the other. Okay? They're used to change the direction of the force, change the type of the movement, speed, torque, force. We've worked with some of these so far. One thing you need to know is that meshed gears in a gear train always turn in opposite directions, and the flow of power is reversible only if you can make the input shaft turn by turning the output shaft. And we've done a little bit of this, but we haven't exactly run into something that can't be turned. When we use worm gears, you'll be able to see that turning the input shaft and the output shaft don't always work together at the same time. Mechanisms. The movements, we have rotary movement, oscillating, linear, and reciprocating. Some of these, the spring here, it has a spring for reciprocating, but for this one I really want you to think of a reciprocating saw where the input is one constant motion but the output is reciprocating. Oscillating, if you look right here, we have a swing set. Now we know with a swing set you have to actually push and change your body weight. So a true oscillating would be something like a fan, where the motor is continuously spinning in the same direction, yet the fan is going left and then right, back and forth. And linear, this is a really good example of linear, where you have one rotary movement that is then forcing something to move in a linear fashion. Changing speed. Gear ratios, output as compared to input. So the output is the driven gear, the input is the drive gear. So this one right here, we see right here we have the driver and the follower, which would be the drive gear. This would be the driven gear. If the drive gear is turning to the right, then the follower or driven gear is going to turn to the left. The way that we can determine the gear ratios themselves are through using the number of teeth or the diameter of the gear. Right here we have number of teeth and diameter. So gear ratio over 1. We're going to discuss this a little more. You've used some in class, but we haven't really discussed how do we use this to help us to build different mechanisms. These two things right here. If the output gear is larger than the input gear, the speed will decrease. And if the output gear is smaller than the input gear, the speed will increase. You need to make sure that those are written down in your journal. So go ahead and pause this video, go write it down, and then once you've written that down, go ahead and push play again. Mechanisms. We change force. There are two different forces we're going to discuss. This should already be written down in your journal. So we have a push force, goes in a straight line, and torque is a push or pull in a circular direction. So we have a force and then a torque. So when I talk about torque, it's always going to be circular in motion. Simple gear trains. Now, something we need to know about these. You've already built A, and we're working on B tomorrow in class. So one is we have, I go ahead and put these up so we can all go through them together. We have input and output shafts are parallel right here. So A, the speed is constant, but if we look at B, the speed is increased because this is the drive gear, this is the driven gear. In A, the torque is constant, B, the torque is decreased. The ratio for A is 1 to 1, and the ratio for B is 36 teeth to 60 teeth, or 3 to 5. And the flow of power is reversible. That's a major thing you need to look at. Can you turn both sides and the mechanism not get bound up? And the gear direction. In both of these, the gears are opposite in direction. Where do we find these simple gears? There's a lot of different places, maybe watches, sewing machines. I want you to write down in your book, simple gear train, just like you see right here. And then underneath it, put one or two examples of a gear train that you know that you've seen somewhere. Maybe it's in some type of car, maybe it's in a device at your house. And here's an explanation for it. Two meshed gears will rotate in opposite direction. So this is something you have to remember. They will always turn in opposite directions. Simple gear train with idler. This is something we're getting to next and we're going to build. So what's the purpose of an idler? This little gear in the middle, the idler. The input and the output shafts are parallel. The speed is constant. Torque is constant. Ratio is 1 to 1. The flow of power is reversible. And the input and the output gears go in the same direction. Without the idlers, they go in different directions. Now how can that be? We have a large gear here, then a smaller gear, and the large gear here. So how's the ratio the same? Well, this smaller one right here, this idler, is just transferring power from one to the other, because this larger one and this larger one are the exact same size. We'll discuss this a little more in depth because you'll run into a few gears and trains that have multiple different gears all throughout at different sizes, but then at the end you still end up with a 1-to-1 ratio. Okay, where do we find simple gear trains with an idler? So two mesh gears will rotate in opposite direction. An idler gear allows the drive and driven gears to rotate in the same direction. If we look right here, you'll see this little gear in the middle. This is the idler gear. It's allowing this gear system and this gear system to turn in the same direction. That way, when paper is flowing over it or under it, it's not going to bind. Because if you have two pieces turning in opposite directions, the piece of paper will not go through the area in which it needs to follow. Now, bevel gear. We haven't built this yet, but we will get to it. This one has to do more with changing the direction. Oh, a little too far. Angle, we're at a 90-degree angle. Speed, constant. Torque, constant. Input is greater than output. So increase, the speed will increase, torque will decrease. Gear ratio, 1-to-1. And the flow of power is reversible. So if you turn one side, it will also turn the other side. We're going to spend some more time on the bevel gear possibly later this week. But where do we find a bevel gear? They're found in hand drills, car differentials, and drive shaft driven bicycles. So we have some bicycles, most of the bikes we run into have chains on them, but there are some that actually have a drive shaft on them. The bevel gear is used to change rotational motion at a 90-degree angle. Using gears with different numbers of teeth will change the speed and torque. So if we look right here, we have this gear which has less teeth than this gear. If we turn the shaft here, make this our input and this our output, then we will have a greater amount of what? Torque or speed. We'll actually have a greater amount of torque because this is a smaller gear and this is a larger gear. Or the diameters are smaller on the input versus the output, and the number of teeth are less on the input than the output. Differential gear. This one you will not be building. However, you will need to understand it. So it uses a bevel gear. The axles turn in the same direction. It's used in automobiles, cars, and the purpose. The wheels spin at different speeds when turning. We have a link right here that you can click on your own if you download this slide. But this is something that you can just experience as you watch or look at it in the classroom. So come by my classroom and take a look at it, play with it, turn it, move it. Main reason we won't be building it is I don't have a whole lot of these differentials. But you are welcome to come in on your own time and build one if you would like. Worm and wheel. We're going to go and stop here at the worm and wheel. And the next video you have, we'll discuss how the worm and wheel works. And hopefully by that time we'll actually be building it in the classroom. So thanks, and I hope to see you in the class.